So my name is Nick Macro, and this talk is Pandas on Jupyter, Improving Your Data Analysis Workflow. So first, let's start with a little bit about me. I am a physics graduate student here at OSU in the Zong group. We measure and analyze a lot of time-dependent spectroscopic data. That means we work with a lot of tabular data. And I am personally very passionate about transparent data analysis methods and laboratory methods, and that is what brought me to the Python community, and in particular, the Jupyter community. So now an overview for this talk. First, we'll talk about two tools, Pandas and Jupyter, as the title suggests. Then we'll compare and contrast two different data analysis workflows, one using Excel and one using Jupyter Notebooks. Then we will go ahead and discuss incremental steps we can take to go from the Excel data analysis workflow to that Jupyter data analysis workflow. So first, Jupyter. Probably heard of it by now. It is an open source interactive programming environment. It consists of many cells which are executed sequentially. So you'll have an input cell that can be a code cell or a markdown cell. Then you execute that, and you'll have an output. You can create custom widgets for interactivity. That's not what we're going to talk about today, but it's very good to know that you can make some really cool interactive tools, and that's really blossoming, especially this year. And it's language agnostic. Let's say you have colleagues that don't use Python, shame on them, but they use Fortran or R or Julia or maybe some other language. They can either make their own kernel for Jupyter or use a kernel that exists already. And you can also export it. So not everyone likes to use Jupyter Notebooks, and that's OK. We can go ahead and export it as a PDF or as LaTeX so that you can adjust it a little bit, or as Reveal.js slides. So next, when you start an instance of a Jupyter Lab, you'll see this. You can go ahead and make your own notebook, make your own interactive Python environment, or you can have a terminal or text editor. So now let's go ahead and click on the left side where we have our Files tab. And that creates, or that opens your File Explorer for whatever folder you're in when you open up this Jupyter Lab instance. So here we'll go ahead and open this Jupyter notebook that we'll use today. So we're not going to dive too deep. This is just what it would look like in the wild. And this is the analysis code that we'll use in future slides. So here you can immediately see we have some markdown that explains what we're doing. You're running some code. So this is the first input, and then you have the corresponding output, and so on and so forth. So here, the really nice thing that makes it really reproducible is you have the code that's generating your outputs all together, bundled up, and it's not you have some code over here making some outputs over here, and they get disjointed, and then in 10 years when you're trying to think about what happened, who knows what created this figure or what created this analysis. So next, Pandas. So as the title suggests, we're also going to talk about Pandas. This is an open source Python library. It's primarily used for organizing and manipulating data. So it's basically spreadsheets for Python. You have two different data structures. You have the series structure, which is a one-dimensional structure that has index names and index values. So it's basically a dictionary. And then you have a two-dimensional structure, which is a data frame, where you have columns and rows. Those have labels, and for each of them, you have values at each intersection. And you can also hierarchically structure both your rows and your columns to support data that is greater than 2 dimensions. So if you have a 10-dimensional data set, you can represent it in a data frame fairly quickly, fairly easily. And now you can also visualize a lot of your values quite quickly using built-in functions. That's what we'll use today. And you can transform, filter, or group your data quite quickly and seamlessly. So now let's look at what a data analysis workflow looks like in Excel. So probably everyone started out doing data analysis in Excel, and that's because it's fairly easy to use. So that's definitely a positive. It's a familiar environment because that's how most people learn how to do it. You don't need very much coding knowledge, and it's really good for quick visualizations. If you just want to see a trend or see some type of relationship, you can do that fairly quickly in Excel. And because it's a widely used tool, it's easy to share. However, there are some downsides. So just like I mentioned before, where you might have some output and you don't really remember or know how the input was generated, we we have that same problem here where maybe your cells are all scrambled around. I've seen some Excel spreadsheets where it's fairly opaque as to what's happening, and you really have to spend a lot of time investigating and becoming a detective and thinking about, okay, what did they do, track all the cells around, and it takes a lot of time and effort. And it's also harder to scale to large data sets. So if you have a lot of data, it can become cumbersome to iterate over those large data sets. And if you need an external program, so let's say you want to do some nonlinear fitting, that's what we like to do. You might need to take your data from your Excel spreadsheet, put it into a nonlinear fitting program, and then put it back into Excel. So that's what I've seen in my group in particular. So next, onto the Python workflow. So if we just imagine a generic workflow, in Python, it's nice and automatable and scalable because it is done programmatically. You're not manually shuttling things around or doing anything like that. It's nice and testable, which means you can do TDD if you want. You can have a test code or a test data set, perform your analysis on that data set, make sure everything is good and happy, and then apply it to your much larger data set. You can also, just like we saw in the preview of the Jupyter Notebook, we can have a really transparent and reproducible pipeline for our data analysis. There's nothing hidden. There's nothing that's obfuscated. And with those markdown cells, we can go ahead and document things quite directly. The downside is you need to know how to program. Not everyone knows how to do that. So hopefully, if you're here, you're very motivated to learn how to do Python. So you do need to know how to program, and I think that is the main downside, and that takes some time. So now how do we go from that Excel data analysis workflow to the Python data analysis workflow? Well, we have a nice roadmap. First, get your data into Python. And that can actually take a decent amount of time if you have a complicated and highly structured data set. And let's go ahead and look at the data set for today's example. So this is a data set about cars. So it is a tidy data set. What that means is each row is an instance of one measurement, and each column is an attribute. So what that means is each row is an individual car, and each column is a fact about that car. So we have columns for acceleration, the number of cylinders, the displacement of the engine, the horsepower of the vehicle, the fuel efficiency, miles per gallon, the name of the car, the origin of manufacturing, and the year it was built. And each row is a unique car. So first, let's go ahead and start out by importing Pandas and importing matplotlib. So we'll go ahead and import Pandas as PD. And we're just going to use matplotlib here to maybe make some things a little bit larger just so they're easier to present. We're not going to do any sophisticated matplotlib plotting. So everything is going to be done in Pandas. And the Pandas version to kind of future-proof this, hopefully, is 0.23.0. So next, let's try to import this data using the simplest conceivable way to import a CSV. So we'll call pandas.readCSV. Let's see if this works. So we're going to read the CSV, and we're going to display the first five rows here using the head. So we'll go ahead and look at that. And you see everything came in as we expect. There were no problems. The read CSV worked. So in bold, these are our column labels and our row labels. So the row labels are counting labels. They go from 0 to 1 minus the number of entries that you have. And nothing got mangled. So you want to double check that you didn't get any missing values because something was parsed incorrectly. So everything looks OK. So we can go ahead and look at this further. So we only look at the first 5 rows. Let's go ahead and look at the shape of this. We have 9 columns and 406 rows. That's what we expect. If we look at our data elsewhere, we see that the number of rows is 406. So nothing got mangled. And we can go ahead and look at the unique values in that year column. So we'll go ahead and access the year column and ask for the unique values. And we see that we have an array of June 1st of some year. So let's go ahead and have our first task be to clean up that column. So step 2 on our roadmap, perform a single instance of one analysis text. So it's really easy to where you have this workflow that's really complicated, and you need to be able to do it piecewise, and you don't want to have to reinvent all of these wheels that you have working to just cleaner year column. So first, we'll go ahead and access. So we're going to, from our data frame, we'll do the dot block. So that accesses it by label. We'll say we want the 0 labeled row, so that's the first row, and that year column. We'll go ahead and output that date. So that's your January 1st, 1970. Now we can take the last 4 characters and typecast it to an integer. So now we have 1,970, that's what we want. But now remember, this is not adjusting the value in the data frame itself. We extracted that value, we modified it, but we have not put that value back into the data frame. So here, we have the same exact operation. We're making a copy of it so that when we perform future analysis or future modifications, we don't change it with this. So we're always working with a clean set. Now we're going to go ahead and ask for that. We're going to go ahead and ask for that value, modify it, and we're going to say we're going to set the value at that location to the modified value. And we're going to look at the first 3 rows. So you can see on the right-hand side that the year for the first row is now 1,970, and it is not January 1st, 1970. And you'll notice that columns can handle multiple types. So you have the first row, the year column, that is an integer, and the subsequent rows have strings. So now, third step on our roadmap, write a function for that single test. So this is a rudimentary example. I think that this is hopefully something that everyone can follow. And this, you might say, doesn't necessarily need an example, but I think it's good to say that you should write a function, for example, and see why I'm going. So here we're going to go ahead and define a function that is getYear. So you'll do exactly what we did before. Extract the last 4 characters, typecast it into an int, and return it. Next, so that was easy. Next, automate that task by iterating over more data. So we have a whole column of data. We don't want to just change one value. Let's change all of them. Next, we're going to go ahead and get a clean copy once again. And then we'll call the clean.iterRow. So this will iterate over every row. It will return a tuple. And the first value of the tuple will be the index label. And the second value will be that row itself. So now we can go ahead and ask for that year column, or that year value, and apply our function. So we're going to go ahead and extract that year value and apply it back into the data frame itself. And we can ask for the unique values. So here we have every year in integer form. So that's what we wanted to do. Perfect. Now you might say, well, this could get really sketchy and really complicated if I'm doing my super sophisticated, awesome, best analysis ever to a single column. Well, that's okay, because we have an apply method. So instead of going and iterating through everything, you can apply a function to this column. So let's break it down real quick. We're making another copy. We're setting the value of our clean column at year, or the year column, to the year column that has the getYear function applied to it. And let's make sure it works. Perfect. So you can apply functions to an entire data frame. You can apply it to a column or a row. This is a fairly powerful tool. Now output the result. So I showed you all of the values for that column, but hopefully we don't know if we mangled anything else because other columns might be affected. So let's double check that we didn't hurt anything else. So we'll go ahead and print out the first 3 rows and the unique values once again. So here we print out our rows. The first 3 rows, nothing got changed. We didn't accidentally delete our miles per gallon column. We didn't destroy anything that we want to keep in the future. And once again, all of our years look good. So now, step 6, rinse, lather, repeat. So repeat all of the steps 2 to 5 for your additional tasks. So you perform one task, and you want to now just keep cycling through. Once you have your data in Python, that might be your most time-consuming step, actually getting your complex data set into there. And you don't need a CSV. You can import SQL, JSON data. There are a lot of data types that are supported. Right? So now let's go through a couple more tasks to hopefully show the basic power of Pandas. So first, let's plot various column values versus time. So here we have we're going to go ahead and call the plot method for our clean data frame. We'll set the x value to year, and 1981 is missing, which you probably saw if you're very astute in the unique list, but it's much easier to see here. And we can see a trend. It's increasing, so we're definitely saving here. So now, let's go ahead and follow that roadmap and iterate over more columns. So just for the purpose of the presentation, I'm only going to iterate over the miles per gallon, the displacement, and the year. You can iterate over all of them. So what we're going to do is we're going to go ahead and iterate over that list, and we're going to set the x value to be the year, and the y value to be whatever we have in that list. And we're going to apply each one. So in the Jupyter Notebook, so once again, remember, all the slides that I've been showing you are what you would see in a Jupyter Notebook. You have your code, and then the output, and their links. There's no magic happening in between the two. Here, these would be sequentially printed vertically, but just for the slides that they're printed out by Photoshop or painted it and the horizontal. So you'll see that, as we saw previously, you have your miles per gallon versus year, then you also have your displacement versus year. And that kind of looks, maybe we can convince ourselves that it's going down, that's decreasing. And what I always like to do is I like to have a sanity check. So I'm plotting year by year, because we don't know, if this plot function is kind of a black box. We don't know if it's doing something sketchy in the background, and these can hopefully catch that type of situation. The next step, let's plot a correlation matrix. So what a correlation matrix is we're basically going to take those three plots where we had some column value by some other column value, and we're going to apply that to all the columns. So here, what we're going to do is we're going to go ahead and create a new data frame. That's going to be this clean.lock. We're going to take all the rows, and we're going to only extract those plot columns that we asked for before. So that will have your miles per gallon, that will have your displacement of your engine, and your year. So then what we're going to do is we're going to set the axes here. All this is doing is making the font bigger. That's all it's doing. So there's nothing scary is happening. All the magic is happening in this pandas.plotting.scatter matrix. So we're giving it the data. We're saying we want our figure size to be 20 by 20 inches. And along the diagonal, we want a histogram. So what does that look like? That looks like this. So here, now this is once again one line of code. Our diagonal, this is a histogram of the corresponding x values. So miles per gallon, we have a histogram for all of the instances of the miles per gallon. Displacement, so on and so forth. So here, this replicate, or this, we did some analysis we did before. So we still have our year by displacement and our year by miles per gallon. However, we gained an additional one. We gained displacement versus miles per gallon. So you can see that as your miles per gallon increases, your displacement decreases. So those are negatively correlated. Now, we can apply it. Unfortunately, it didn't look very good on the presentation, but you can apply this to a data frame that's as large as you want. So here you can see the entire correlation matrix for all the data in that data. So now, we have a bunch of dots here. And it's kind of hard for us to infer what's happening because we have a lot of data. Let's go ahead and average over all the years. So we have a bunch of cars that were produced at a specific year. Let's go ahead and average all those values. So our next task, let's average over each year's values. So what we're going to do is we're going to go ahead and apply the group by method. So we're saying we want to group by the year. Set index is false. What it's saying is we don't want you to set the actual year to be the index label. We want the year to remain a column. So we want to have that index still remain 0, 1, 2, 3, so on and so forth. And we're going to go ahead and apply the average. So you don't have to average it. You can do a sum. You can perform a standard deviation. You can do a bunch of different aggregation techniques. And we're going to print the first 5 rows. So here we go. We still have all of our, and you'll notice that it dropped any columns that it had strings. So you can't apply a mean to a string, so it inferred that you didn't want that, and it dropped that. You have your year, acceleration, cylinder, so on and so forth, and your row labels are 0 to 4, because we're only printing the first 5 rows. So let's go ahead and plot it. So we're going to go ahead and group by again, pull out that miles per gallon column, apply the mean, and plot it. And we can we're also going to set the y label to miles per gallon because of the way we're performing this plot, it doesn't do that automatically. And we can see it's a little clearer here when we take the average what's actually happening. So now we can, once again, iterate over more data. We have more columns. So this is the same exact data we saw before. And remember how I said it was, you have it, at least for myself, I had to convince myself that the displacement was going down over time, and it's definitely going down. You can see it increases by more than a factor of 2. So we also have that sanity check where, once again, we're using a new plotting method. This is the line plot instead of a scatter plot. So we have the sanity check over here. And we can perform the scatter matrix with this. So we have less data, so it might be easier to see things. Here we have a groups. We're going to go ahead and group by year, same as before. And we're applying that to the plot data so that we have fewer columns. And we're going to do the same process as before. So we're going to get that scatter matrix and make the font a little bit bigger. And you can see here, now we have fewer dots. So we have 1 dot per year. And that's all of the cars averaged together. So you can see miles per gallon over year increase as we saw. The displacement over year decreased. Now our new data that we're interested in is our displacement versus miles per gallon, and that definitely decreased. That's definitely negative before. So once again, to reiterate our roadmap, we can first get your data into Python. Second, create one analysis task that you're already performing or want to perform. You have a new analysis that you want to do. Next, make that a function. After that, go ahead and automate that over more data. So you don't need to create an analysis task for all of your data. Just do it on the simplest atomic piece that you can. Next, output the result to make sure that everything is happening as you expect. Check your analysis. And 6, repeat over all the other steps. Remember, you don't need to do your entire analysis or reinvent it in one go. You can reinvent it gradually. You can adjust things gradually. So in summary, Pandas and Jupyter are excellent tools that can be used to perform transparent data analysis. So hopefully you saw or convinced that you can kind of have inextricably linked code to output. So you're not having to fish around and think about, oh, I have 10 different versions of this analysis. I have all the outputs. What code generated that? And you can also use incremental improvements to improve your data analysis. You don't need to do it one fell swoop. Thank you very much. Since we have extra time, we can take questions. Yes?
So on one of your slides, you had something about testable data analysis. So what exactly does that mean?
So the question is, on one of my slides, I talk about how data analysis can be testable. What do I mean by that? So what I mean by that is you can create or have already data analysis that you know the behavior of, right? So let's say you have on here miles per gallon. Let's say we know that the average should be 50 for some year. You could apply that, and let's say you get more car data. You could then apply, or hopefully you would be confident that you can apply your analysis to the new data, and you wouldn't have to reinvent anything. So you can have small subsets of your data apply to that. You know you have known characteristics, and you can have known behavior.
Do you know of any like Python libraries that do that for you?
I mean, so you can create. It depends on how general you want to go. You can use any unit testing framework to do that, where you just feed in a test set of data and do that. You can also do hypothesis testing to make it much more general, and that will test a wide gamut of values. But I think that might be overkill. It depends on what your use case is.
Thank you.
Any other questions? All right. If not, I'll be hanging out in the hallway for a while. And if you have so I also love to collaborate online. If you have questions or you think that you need some help converting your data analysis to something more reproducible, please talk to me on either GitHub or Twitter, and I'll be posting the slides and the Jupyter Notebook that was used to make all this stuff on my Twitter or on my